Hey guys, Miss Barber here to present to you lesson 1.1, the first lesson in geometry, points, lines, and planes. So our learning objective is to identify and name, draw points, lines, segments, rays, and planes. So that's what we're going to be focused on today for today's lesson. The first definition, our most basic geometric figure that we can come up with, is called a point. A point is simply a location, a dot on the paper. It has no size, it has no space or shape, and we always name it by one capital letter. Naming things is going to become really important later on because we have to know how to talk about it. So here we have a dot X, so we can just call it point X or just the letter X, always a capital letter. And again, it's just a single location in space, no shape, no size. Now, if we have 2 points, for example, here we have point A and point B. From 2 points, we can draw a line through it. A line in geometry is always going to be straight, and a line has 2 arrows at the end. A line is one-dimensional, so it goes off in opposite directions. And you name it by 2 points that are on the line. So in this case, we could name this line AB, the 2 capital letters on line AB, and we draw the line symbol with arrows. Order doesn't matter, so BA would also be an acceptable name for this line. Because these lines have arrows, that means that they go off infinitely in either direction. So you should ask yourself, can you take a ruler and measure the length of a line? The answer is no, you cannot, because it goes off forever and ever. It's impossible to actually measure the length of a line. Now, it's very important to also remember that a line is named by 2 points and any 2 points on the line. In this picture, there's only 2 points, but I could easily draw in a third, so I'm going to draw in a dot and call it point C. I could also call this line AC. I could also call it CB or BC, so lots of different names for this line. You might want to use 3 points because you see 3 points there. However, that's incorrect. You have to use only 2 points. Finally, one last way to name a line. You might see this little m here in the corner. It is a lowercase cursive letter. It does not have a dot next to it. It is not a point. It's just simply a nickname for the line. So another way you can name this line is by calling it line M with a lowercase m. So again, just another way to name the line. And then third, we have a plane. A point is a single point. 2 points make a line. 3 points in this kind of triangular shape are going to make a plane. A plane is 2-dimensional. It goes off in infinitely many directions. So on our paper, we just show it with a box, but it's important to note that it's actually going all the way to the left, all the way to the right, all the way up and down. So think of it as like the floor or a wall, a sheet of paper, but that continues to extend on beyond what you can see. You name a plane, by the 3 points that are on the plane that create this triangular shape. You don't want them to be all on the same line. So we can use the plane symbol, which is this squared off shape, and call it ABC. You could call it CAB. Order of these 3 points doesn't matter. If there was a 4th point there, you could use that 4th point, but again, you're only going to name it with 3 points, never more, never less. Just like with lines, there's also another way you can name a plane, and that's with this uppercase cursive letter K that's in the corner. Again, no dot there. It's not a point. It's just a nickname for the plane. So another way you can name this as plane K. Again, it's not a point. You can't use it to name anything other than this plane. It's just a shortcut because once we get talking about a lot of things, it might be easier just to name it plane K. So those are the 3 first basic definitions in geometry. Geometry is full of definitions, so we're going to be learning a lot this year. The next one is a postulate. A postulate is a really weird word that all it means is a true statement. We take it to be fact. So something you know to be true, you don't have to prove it or anything like that. The line postulate has a lot to do with the line definition. Through any 2 points, so no matter where I draw 2 points in this world or on my paper, I should be able to draw a straight line. Again, all lines are straight in geometry through it. Arrows at the end, it extends on forever and ever. So through any 2 points, there is exactly one line, and I can always be able to draw it. The second postulate is the plane postulate. The plane postulate has a lot to do with the definition of a plane. So a plane has 3 points. So I have to draw 3 points. However, they have to be in sort of a triangular shape. They can't all be on the same line. There is exactly one plane. So through any 3 points, I can draw a plane around it. I don't want to just draw 3 points all on the same line because then I'm really just naming a line with extra points. So again, through any 3 points, there's exactly one line. Or any 2 points, there's exactly one line. Any 3 points not on the same line, there's exactly one plane. There's a definition for that a little bit later. Moving on, we have a segment. So a segment is a line segment. You might notice it differs slightly from a line is that it has these 2 endpoints. So a segment has a distance. It has 2 endpoints and the space between. You could get a ruler out and measure a line segment. So a line segment you name in the same way you name a line. However, you don't draw the arrows above it because it's not extending on forever and ever. It's just the distance between A and B. The distance between A and B is the same as the distance between B and A, so you can write it the opposite way. Only way to name a line segment is through these endpoints. A ray is a combo of segments and lines. It has one endpoint. So here is endpoint A. Like lines and segments, a ray also has to have a second point. So in this case, it's B. But a ray consists of one endpoint and then extends on infinitely in one direction, through another point. Very, very, very important. We know that you have to name a ray starting with its endpoint in front. In this case, our endpoint is going to be A. That's where the ray stops. It does not extend on past A to the left. So the name of this ray would be A, B. Starting with A as an endpoint, so no arrow, going off to B with an arrow. Just like lines and segments, 2 points, there could be a third point listed. So let me go ahead and put in point C. Doesn't matter I put it on the ray, I'm going to put it in between A and B. Here's point C. I could also name this ray AC. It still has that same endpoint A. It's still going off in the same direction. Again, if I trace over A and trace over C, I'm still extending off right. So my ray is still the same ray, just another way to name it. Endpoint always in front. So A here, always in front. Opposite rays should look like something to you. And if you're thinking, what do they look like? They look like a line. Opposite rays are 2 rays that have the same endpoint. So the endpoint in this case has to be in the middle. So X is my endpoint for both rays. One ray starts at X and extends on to the left. So this ray would be named, again, endpoint first, X, Y. Starts at X, extends off to the left infinitely to Y. The other ray would be named X, Z. Starts at X, extends infinitely to the right at Z. So we would name this ray XZ. Opposite rays have to have the same endpoint, so they both have this endpoint X. And they have to continue infinitely in opposite directions. So think exactly 180 degrees. They are forming a straight line. So it should look like a line. If it's not 180 degrees as a straight line, that's actually called an angle, which we'll learn in section 1.3. Two more definitions that you're going to need to know. First one is collinear. You should think co, the prefix co means with, and linear has the root of line. So with line. Collinear means points on the same line. So 2 points, draw a line through it, they're collinear, they're on the same line. So coplanar here, again, co means with, now the root word is plane. So coplanar is points that lie on the same plane. The definition of collinear we could actually use up at the top. So collinear, points on the same line. Here for the plane postulate, where it says through any 3 points not on the same line, we could use the word not collinear. They can't be on the same line. So not collinear would be a good add-on to that definition. 3 points, not collinear, will make a plane. All right, so those are the last definitions for this little part of the section. Now let's actually put these definitions to use. Example 1A, give 2 other names for line EF. That's a line. There are arrows on top of E and F. So let's go ahead and locate E and F. Here's point E, here's point F. If I draw a line through it with my arrows, that's the line I'm talking about. Given any line or line segment, you can always just do the reverse lettering, and that will give you a correct answer. So FE will also be the answer. And it says give 2 other names. So FE, you could scan my orange line here and think, are there any other points? There are no other points, so there's nothing else I can use. There is, though, this little lowercase m, no dot next to it, not a point, but another name. It's the nickname. I could call this line M. So that's letter A. Letter B, give another name for plane A. You might be thinking, plane definition, you use 3 points, not collinear, not on the same line. Here's A, the letter. It was the nickname for this plane. Again, plane we usually represent with these parallelograms. I see lots of points within my green box. I see point C, point E, D, and B. I only use 3 and exactly 3 to name this plane. Does not matter what order I list these 3 points that I choose. It's just very important that I don't choose 3 that are on the same line. C, E, and D are all on the same line, so I'm going to be careful to not choose C, E, and D. So instead, I'm going to call it plane CEB. You could call it BED, DEB, CBE. Order of the letters does not matter as long as you do not choose CED. So that leads us into letter C. Name 3 points that are collinear. Well, C, E, and D are all on the same line. We needed to know that to correctly answer letter B. Letter D, 4 points that are coplanar, 4 points on the same plane, the 4 that we highlighted in green. C, E, D, and B. F, this point here, F is lying above the plane. So think of it as a sheet of paper or the tabletop desk. You can hold your hand above the desk. So that would be like a point above the plane. Letter E, give another name for segment EF. Notice there's no arrows above E and F. So the only other way you can name a segment, because it does not continue on forever and ever, is to just change the order. So segment FE. And then letter F says name a ray with endpoint E. So let's make sure we locate E. I know my picture's getting a little confusing now. I'll try to highlight it in yellow. E, that is opposite rays of EC. Well, EC kind of goes in this diagonal downward left direction. I know in order for it to be an opposite ray, I have to use the exact same endpoint, so I have to use E and go off in the opposite direction. The only other point I see this right ray going through is D. So ED, again, endpoint first, ED would be my opposite ray. N, think to yourself, why did I not use N? ends not a point. That's just a nickname for that line that's now yellow. So I can't use that. ED is my only option. What you should do now is pause the video and try numbers 1 through 6 on your own. Remember, the key is on our school website, so feel free on Schoology to look at that and double check that you got them correct. Finally, intersections. Intersections, you interact with these every single day. When you're walking to school, you have to cross busy roads, and where those roads meet are intersections. So intersections are just where geometric figures cross, meet, overlap. 2 lines here on my left intersect at a single spot in space. Well, we know that single spot in space to be a point. So if you think about it, if you name 2 streets that intersect, you know exactly where that intersection is. Little Mac and 11 Mile, those intersect at exactly one spot where you could tell somebody to come pick you up from school. So example, name the intersection of LM. So let's locate LM. Here's L and M. So we're talking about this whole line here, extends on forever and ever. And PM. Here's P, here's M. Again, draw a line through it. Both of these have M in it. Notice they're crossing right at M. So the answer here is just point M, or just capital letter M. Now, 2 planes intersect in a one-dimensional figure. What I just highlighted. Hopefully to you that looks like a line. Think about how the ceiling and the wall meet. They don't just meet at one spot. They meet at many spots in a row. They meet at a line. So name the intersection of plane D and plane A. So these are the 2 planes here on my right. And this line is going through them. So I can name that line with any 2 points it crossed. So I'm going to go ahead and name it XZ. You didn't need to name it XZ. You could have named it ZX. You could have also named it RZ. I'll write that one down if you liked that name better. ZR works. XR works as well. 2 planes intersect at a line. And again, very important that we add those arrows. It's the line. Extends on for an ever and ever. Finally, a plane and a line. So think about a piece of paper, and if you stabbed your pencil through it, if you pulled your pencil out, what would be left? Hopefully you're thinking, well, a hole would be left. Well, a hole, geometric figure, is a point. So a line and a plane intersect at one single point. So name the intersection of plane HEF. So let's locate HEF and draw out this plane. So HEF. So that's like this top part of this box here. And line GC. So I'm going to find G and C. Here's G, here's C, and that's my line. They should overlap at one single point, and I definitely see that point where my yellow and my green overlap, and that is point G. So again, this left-hand side here is what you need to remember. 2 lines intersect at a point, 2 planes intersect at a line, and a plane and a line intersect at a point. That should be enough to answer the rest of these questions. So, let's try a couple more together, and then you can figure out the rest of these on your own. So let's do number 7. 3 collinear points. If you forgot what the definition of collinear is, you should scroll up. Co means with, linear is line, so 3 points with each other on the same line. I need to find 3 on the same line. There's more than one answer, but I see A, P, and B all on the same line, so that's what I'm going to use. J, D, and K would also have been acceptable, as would have been D, P, and C. So lots of options here. We're going to skip over number 8. You can try that one on your own. Number 9, 2 lines that intersect CD. So let's go ahead and find C and D. I'll highlight that here in orange. So here is C, and here is D. So we're talking about CD here. What lines intersect that? So where what other lines cross it? Well, this line here on the left crosses it. I'm only going to use 2 points to name it. So this green line I'm going to call AP. You could have also called it AB, but again, only use 2 points. As well as this line going up and down also crosses my orange line. You can use whichever 2 points on that blue line you would like, but I'm going to call it JK. All right. Number 10, name the intersection of JK and plane R. Well, JK we just called, it was that blue line. Plane R is the big grayed out plane there. Well, you have to think, a line and a plane, what is it going to intersect at? Well, right above we said a line and a plane intersect at a point. So the question is where is that point? Well, if you look, we have this line going from J, it goes down to D here, and then these dots means it's going behind or underneath the plane and back out through. So point D is where this intersection is occurring. All right, last one we'll do together is number 11. And again, always check your answer against the key online. Number 11, the intersection of plane KAG. So we're going to use our new picture now. And in red, I'm going to highlight KA and G. So this plane is this triangular face on this prism. And plane BEG. So I'm going to locate BE and G here with blue. B, E, and G is this bottom face of this prism. You should be able to see from the highlighting where these 2 planes intersect. Again, look above. 2 planes are always going to intersect at a line. Well, this line, it's gotten kind of hard to see, but K and G are the 2 points that make up this line. So KG would be the intersection where these 2 planes meet. That's it for 1.1. I hope that you learned something and that this will be very helpful for the coming